I explained to you a moment before how boilers work. Now we also need to take like a proper look at the steam systems. So the first thing, let's draw a boiler. Let's imagine that this is our boiler. Okay. Oh, no. I'm not a good artist to draw. You like that? Okay. So this is our boiler. At the top, yeah, here, we have our steam drum. At the bottom, we have our water drum. I think that's simple. So then at the very top of the boiler, somewhere here, we have main steam valve. So why do we need main steam valve? I will tell you, like, wait, main steam valve. So when we open our main steam valve, all the steam that we have in our steam drum goes to our consumers. I will like draw that in a moment. So somewhere here, let's imagine that we have a kind of consumers. So you can ask me like, Alex, what's consumers? Consumers are maybe your fuel tanks, maybe some kind of heaters and blah, 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 blah. So that's actually where you use your steam. All right. So all the steam that we have from steam drum goes to your consumers. Like, like for fuel tanks, for oil tanks, for sludge tanks, for dirty oil tanks, for all kind of tanks that we have. So after that, after your consumers, somewhere here, you should have a condenser, like a kind of atmospheric condenser. By the way, a question for you. How condenser is cooled?
By the seawater?
Yeah, by the seawater. That's quite simple. So generally we have a condenser which is cooled by seawater. Oh, give me a moment to show you that. So we have inlets, yeah, like seawater in and seawater out. But anyway, that's seawater. Okay. So some parts of our steam goes to condenser. What's the next point? After the condenser, where does the steam go?
Hot well.
Yeah, exactly. It goes directly to hot well. Oh, my bad. So what's hot well? Hot well generally is kind of like a cylinder, container, box. It doesn't matter, like kind of something where you have all your water. By the way, you should remember that the temperature in your hot well must be quite high. So that's about from like 85, let's say from 80, okay, from 80 to 90 degrees centigrade. Yeah, so it's like minimum, that's 80, just minimum. It should be 85, 90. All right. After the hot well, probably we need pumps. So let's imagine that we have two kind of pumps, like pump 1 and pump 2. So these are your feed pumps. Which, by the way, most of the time are centrifugal pumps. All right. Then these pumps actually pump this water back to our water drum. Now, someone asked me about the about the DP transmitter. In our boiler, we can have actually two options to show the level in our boiler. It can be a DP transmitter, and it can be some kind of electrodes in like a kind of also glass. So here we have feed pumps. Also, probably we need some valves. Let's imagine that these are our valves. So before we continue, as you understand, it's quite simple. water from hot well goes to our feed pumps through feed valves to water drum. Burner burns the fuel and maybe have composite boiler, in this case exhaust gases, and together with a burner burns the fuel. So our steam is collected to the top here at the steam drum. Then through the main steam valve, it goes to our consumers, and then it goes back to condenser and to hot well. But you understand that like the water drum, the level in water drum can be different. It can be quite high, it can be low, it can be mid, and so on. So how do we regulate the level of like our water in our boiler? We have two options. So if we talk about the DP transmitter, yeah, I told you that I will explain what DP transmitter is. Generally, DP transmitter is a transmitter, a device. Let's imagine that this is your DP transmitter. So DP transmitter like works, it functions as like a kind of device which understands the balance between like steam drum and water drum. I'll explain that quite like in a simple way. Let's imagine that like from steam drum, there's a tube. This tube is connected to a kind of vessel. I don't like that. Yeah, now it's better. So in a kind of vessel, in this vessel, you have water. Okay. So here we have some water here. Now, because we have some kind of pressure in our steam drum, let's imagine that we have, let's say, 8 bar. Okay. So this pressure pressures this water because water is incompressible. Yeah. And this high pressure side goes to our DP transmitter. So why I like drew that in red color? Because this is actually high pressure side. So it's about like 8 bar. Now from the bottom part, from the water drum, there's also a connection to our DP transmitter. That's actually low pressure. Low pressure. So the difference between like the steam drum and the water drum is inside this DP transmitter. It converts with some kind of electronics. Okay, it converts this difference with some kind of like transmitter, transducer into electric signal. This electric signal can be from 4 to 20 milliamps. So as you understand, 4 means low level and 20 high level. Okay. And then it goes to your engine control room where you can see the level of your boiler. That's quite simple. That's DP transmitter. Okay, somewhere here, we have air valve. Okay, so why do we need this air valve? And what's the air valve for? When you stop the boiler, you need to understand that there should be no vacuum in our boiler. That's why, because of the thermal expansion in our boiler, yeah, temperature can go up or can go down. So in order to avoid, let's say, some cracks and like different problems with our boiler, we need to avoid vacuuming, any kind of vacuum inside the boiler. That's why you need air valve. So generally, at the top of the steam drum, you have a steam like this, air valve. When the pressure, when you stop the boiler, yeah, when you stop the boiler, when the pressure goes like below 1 bar, you open this valve. It's when you stop the boiler. The same happens when you start the boiler. So when you start the boiler, so this valve is open, not closed, it's open. And when you see that only steam, so you started the boiler, And when you see that only steam is coming out from this valve, you can close this valve. That's important to remember, because like when you have about 1 bar, you'll see some steam here. When you see steam, you close this valve. Like that. All right, let's delete that. Okay. Now, jumping back to here. So we check that the air valve is open if the boiler pressure is below 1 bar. Then we start the burner on manual control on low load. We check that the water level does not rise too high during the pressure rising period. If your water level goes up, you have blowing down valves, you blow down the boiler. Why? Because of the thermal expansion, your water level will go up. So that's why you keep like appropriate level. Then, when you see, as I told you, we close the air valve when only steam blows out. After that, we change to automatic control of the burner when the boiler pressure is 0.5 bar lower than the working pressure of the boiler. Simply put, when you have, let's say, 7.8 bar, you change it to automatic mode. If your working pressure is 8 bar, you wait until you have 7.5, and then you change to auto control, like automatic control. Okay? Then you open the main steam valve slowly to heat up and pressurize the steam system. Then generally you open valves to steam consumers. Also, you need to do that slowly. Why? To avoid water chokes, or as we also call it, like hammer effect. So to avoid hammer effect, we need to open all the valves really, really slowly. That's important. And after that, you just check parameters. That's simple.